Welcome to Altair Engineering Training and Support. I am Apur Bapat. Welcome you all in SUPRA SAE India 2016 pre-virtual online training session. The agenda of this training series consists of day 1, day 2, which I have already covered. Now today on day 3, we will see how to do dynamic crash analysis on the roll cage, front impact, side impact and rear impact. Then on day 4, day 5 and day 6 we will see 3D geometry editing, suspension analysis and computational fluid dynamics. So we will start with the model. We'll use the same model which I have done the meshing on day 2. So the same meshed file I will use. As on the model browser you can see I have deleted everything, the material properties and components, load collectors, everything I have deleted. I have just kept the components with the meshed model. For dynamic analysis, I have changed the user profile from OptiStruct to radius block data. So I will select a radius block 120 format. If you are using a different version, then you can select accordingly. That doesn't change the process entirely. The process will be same. It's just the version. So if you are having in your machine, it's block 110, it's still okay. The process is still same. So I select the user profile as radius bulk 120. So I'll start with creating the new material properties as per the dynamic analysis. So first I will click on material collector icon and you can see where my mouse pointer is. This is the material collector icon. I will enter the material name as steel, select a color, type elastoplastic, card image M2 plus Johns, click on create edit. Enter the value of row initial as 7.89 e to the power minus 9 tons per mm cube. Enter the value of E as 2.1 e to the power 5 Newton per mm square, mu as 0.3, A as 180 which is yield stress, B as 230 hardening parameter, N as 0.2 hardening coefficient and sigma maximum as 300 which is the ultimate stress. So I'll click return, again click return. So my material is created now and the model browser you can see that. Now the next step is to create the property. So I will create two properties. I have two components, one is secondary, one is primary. So I will create primary. I will add as 2.2 thickness, 2.2 mm thickness, type as surface, card image as P1 shell, enter the thickness here as 2.2, click on create edit, enter the value of I shell as 24 which defines the type of formulation and N is 5 which defines the number of integration points. Then I will click return, again I will click return. So again I will create one more property as secondary. Here I will change the value as value of thickness to 3. I will rename it, instead of point I will use underscore. So again I will change the color, type surface, card image P1 shell, thickness as 3, create edit, I shell value as 24 which is type of formulation, N is 5 which is the number of integration points. Click return, again click return. So my material is done, property is done. Now I will update the component. So I will click on component collector icon, select the update radio button, select roll cage primary and card image as part, update the property as primary, material as steel, say update. Again I will select the secondary, card image as part, property as secondary, material as steel and update. Now the next step is to create contacts. So to create contacts, I will go to analysis, interfaces, enter the name as contact. The contact type is type 7. Define a color to it. Click on create. Then go to add radio button. Select the masters as comp, slaves as comp. In master, select both the components. Say update. Similarly, select both the components for slave and say update. Now I can review this. If my contact is properly done, then I will see a blue and red dots as you can see at my screen. So now my contacts are properly defined. Now I'll go to card image and click on edit. I will enter the eye stiffness, which is the contact stiffness, as 4. Then gap minimum as 1. And I and act is 6, which define the penetration treatment of nodes. Then I will apply the velocity to this. So I will go to utility. On utility, I will click on BC manager. I will enter the name as velocity, type as initial velocity. On GR nodes, I will select nodes. I will click on these nodes, select all the nodes and say proceed. As you can see, my roll cage is in positive x-axis, so I will enter the velocity direction of positive x-axis, which is 16,667 millimeters per second, and I will click on create. Once you click create, you can review the direction of velocity. If your roll cage is not in a positive direction, then just put a negative so the velocity direction will be proper. Now the next step, as you can see, my velocity direction is proper, so I will close this. So the next step is to define the walls on which my roll cage will impact. So I will create a rigid wall in front of it. So to create a rigid wall, I will go to analysis, rigid wall, enter the name as front wall, select the type as R wall, click create, then go to geometry, select any one node here. I want this node to be a little far from this roll cage so that my roll cage will travel, impact and bounce back. So I will go to edit, change the X distance to 1420, click return. So you can see it is a bit away, and define the normal vector. So as you can see, I cannot use XYZ because it will take the positive direction. So I will use N1, N2 to define the direction. So I will select any two nodes which will define the direction of the wall. So the direction of the wall have to be opposite to the direction of velocity. So you can see my direction of the wall is in this direction. So if you have a doubt that a wall is inclined, you can see here. So you can have if you have a doubt the wall is inclined, so you can create Shift F4, go to Shift F4, duplicate X direction, 10, translate. Then instead of selecting any two nodes, select these two nodes and say update. So now you can see the wall is exactly perpendicular. That is also another way of selecting a proper wall. Then add, go to nodes, instead of nodes select components, or you can select nodes also. Shift F2, I will clear these two nodes. Select nodes all. Deselect these two nodes and say add. So I am just selecting all the nodes which will impact this wall. So once you click review, you can see that these nodes will impact the wall, and these nodes will not pass the wall. They all will get impacted. So the wall size, if you are able to see, this small, but it is infinite wall. You can see the shape as infinite plate. Then I will go to edit. In edit, I can add friction, but in front wall there is no friction, so I will not add anything here. So I will click return. Again click return. So I will go to rigid wall again. I will create one more wall as bottom wall. Select the type as R wall. Change the color to something else. Go to geometry. Select a base node. I want the Z direction to be changed, so I will change the Z direction. So I have changed the Z direction here. Again, for normal vector, you can use any two nodes if you don't think they are aligned properly. So you can change that, or as you can see here, it's a positive Z axis. So you can select the Z axis here and click on update. So I have to create it and go to add and just update. So you can see I have a bottom wall with me, which direction is upwards. So now I will add the nodes all. Deselect this wall node and the other wall node also, this one, keeping all the other as it is. I will say add, then go to cards, and again there is no friction I want to add, so I will click return. Then I have as two components. I will update the output block as output. Instead of nodes, I will select comps, select both the components, create, and then I will click on edit. In variable, I will enter the value as default. So I will enter DEF in capital, say return, again click return. Now I will add some control cards which will help me to solve the models. So I will go to control cards, analysis page, control cards. Go to next. My first control card is engine run. So it's on alphabetical order. So you can find it as engine run. Enter the t-stop value as 0.02, which is the time stop. So this defines for how much time my solver will run. Then you can calculate like the speed of the roll cage and the distance from the wall. So how much time it will take to travel and bounce back, that complete effect you have to capture. So that much time you have to give. You can calculate it easily as per your requirement. Then the next is engine animation DT. So engine animation DT. This defines the time frequency on which you want the animation files. So generally it is 1/10 of the time stop. T stop, that value is of 1/10 or 100. So at every 100 of that T stop, it will generate an animation file. So you will get a smooth animation file. Now one more is engine T file. So I'll go to engine T file. Enter the value of time frequency which defines the points to generate the graph. So this is again the 100 or 1/10 of the animation files. So you will have a smooth graph and some output request as stresses. So I will go to engine animation element, check the box in front of EPSP, that is plastic strain, 1 Mises stress, and hourglass. So these are some cards required to perform the dynamic analysis. Now I will save this file, go to analysis, radius, enter options as both, space, dash, and thread 4. So both will, it will take both the engine and run starter file, and n thread 4 means I am asking the solver to take all the 4 cores of my machine to solve this model, and click on radius. So once you click on radius, it will start solving it. Generally, it will take one hour or 1.5 hours to solve this model. So as you can see, my solver has started. If you have any errors in this, you can take the screenshot of that error and send the HM file along with the screenshot to me so that I can solve that error. It will be easy for me to detect and solve that error. So you can see that my solver has started. So I'll open the hyperview. I have already solved this file. So I'll open the hyperview and show you how to view the results. So I will select A001. From A001 to the last as 609. Say apply. I will split the window into two. Here I will open Hypergraph 2D. Sometimes I got a query that you are not able to see Hypergraph and you are able to see a black screen instead of this. So that is because of the drivers. So you have to update the drivers, graphic drivers, so that you can see that. So here in Hypergraph I will open T01 file. Select global variable, internal energy, kinetic energy, and total energy graph, magnitude, and say apply. So this will create the graph of it. Now I will see the values of stresses, deformations. So I will go to contour, say apply. So in dynamic, you see a dynamic displacement results. So you can see that it is loading at the bottom. You can see it's loading. So it will take some time to load. You can also see the deformation. So my rear roll hoop is deforming, as you can see. The rear roll hoop, rear member is deforming due to the front impact. So you can see it has captured the bounce back effect also. So you can see here, if I put the wall parallelly, so it has impacted and it is bouncing back again. Similarly, I can see the values of stresses. It is again loading, so it will take some time to load. So you can see here the impact has happened and it is bouncing back. So it has captured the complete effect and where the maximum stresses are, at which portion, you can see that also. So if I turn off this bottom and front, so you can see this. So the values of stresses are changing and the maximum stress value point is this. So if I turn off the wireframe mode, so you can see this. So these 2 points are the maximum stress point because of the rear row loop deformation is very high. So you can, with the dynamic analysis, you will able to predict more accurate results and can design a better roll cage. So initially, the stresses are not that high. I will again load the results. Say apply, contour, one minus stresses, simple. Say apply. Dynamic minimum and maximum, deformed edges, turn off bottom handles. So you can see here the one minus stresses initially is 0. So my impact time is 0.02. You can see here, it's quite visible. So you can see at every point my stresses value are changing. So these are the values of maximum stresses. You can also add the minimum ones also. So it will give the both the values, the minimum and the maximum stress locations. So in this way, I have ended with this today's session. If you have any queries, feel free to contact us at edu-support@india.aldia.com, or you can contact me also. Thank you very much for attending this session.